Yes. Let us start. So from that equation, okay. So xp is equal to h cross by 2. So this implies what is p? What is p? P is
H
equal
cross
to,
by
X
2.
by 2x.
very good. P is equal to h cross by 2x. Okay. So
Yes, sir.
right, putting this, you give this is equation number 2 because science and engineering means you have to give the equation. So putting equation 2, right? Putting equation 2 in equation 1. So putting the value of p from equation 2 in equation 1, we get, who can say what we will get? E is equal to, what is our equation 1? P square by 2m.
P
P
square by
square by
2m.
2m means that is h cross by
X.
h cross square by 4s
4x
square. Directly we have to write h cross square by
into
4s
2m.
square. Initially we have 2m plus half m
M omega
Omega
square. X square.
omega s square. So if you do it, it will be h cross square 4 into 2 8 m s square plus half m omega square s square. So now the total energy reduces to this. So this is equation number 3. Everybody, are you writing or not?
Yes,
Yes,
sir.
sir.
E is
Yes,
equal to
sir.
h cross square by 8m s square plus half m omega square s square. Okay. Our objective is we have to find the ground state. Okay. So in the ground state, the oscillator possesses the minimum energy. Okay. So write one sentence. In ground state, the oscillator possess the oscillator possesses minimum energy. The minimum energy. That means E becomes minimum. E is minimum. The value of E will be minimum for x is equal to x0. When position at the ground state, I have taken x0. So this implies let that minimum value is equal to E0 for x is equal to x0. Understood?
Yes, sir.
Yes, sir.
Yes.
Okay. That means look here. This is the ground state. Here this is x is equal to x0. This is E becomes E0. E becomes E0. So that thing I have written here. E becomes E0 when x becomes x0. But our objective is we have to determine the ground state. Okay. So, right. So, right, to find the minimum energy, to find the minimum energy, to find the minimum energy, the condition is we have to apply one condition. The condition is dE by dx, x is equal to x0 is equal to 0. এটা মনে রাখতে পড়িব. You have to remember. Because I think in mathematics you read it, to find the maximum or minimum in case of derivative, you have to take the help of derivative. If you take dE by dx, then x is equal to x0, it becomes 0. Okay. Now, we know energy, you take the derivative d by dx. What is your energy formula? H cross square 8m s square plus half m omega square s square at x is equal to x0 is equal to 0. Pragya, understood?
Yes, sir.
Okay. So you take the derivative d by dx h cross square by 8m s square plus half m omega square s square is equal to 0. Now, Parichay, are you there? Parichay is not there. Gupteswar? No. Okay. Anybody who want to say the answer if you take the derivative? Sonila?
Yes, sir.
Gupteswar, tell me. So, if you take the derivative, what will be your answer? D by dx of h cross square by 8m s square. What will be the answer? Tell me.
कांस्टेंट बाहर चला जाएगा देन एक्स
हाँ,
स्क्वायर का
कांस्टेंट चला जाएगा h क्रॉस स्क्वायर बाई 8m, वो तो कांस्टेंट बाहर चला जाएगा. अभी क्या होगा जल्दी बताओ.
1
बाकी
बाय
हाउस
ये
में हाँ
1 बाय एक्स स्क्वायर का डेरिवेटिव निकलेगा तो
अरे निकलेगा कितना बोलो ना, कितना बोलो, वही चीज मैं पूछ रहा हूँ, कितना बोलो.
-1 by
सर
x
वो
square.
माइनस
1 by s square means x power is -2. What is the derivative of x power -2?
माइनस
-1 by x. -1 by
-2
x.
-2
-2
by
by
x
x
cube.
cube. ओके, ये सेकंड वाला का डेरिवेटिव क्या होगा? हाफ m ओमेगा स्क्वायर एस स्क्वायर का डेरिवेटिव
2x.
क्या हो जाएगा?
2x
2x. ओके, ये हमारा x इज इक्वल टू x0, ये लिमिटिंग वैल्यू है, इज इक्वल टू 0. नेक्स्ट प्रज्ञा बुझेला.
Yes, sir. Yes.
Okay, so now here 2 8 will be cancelled. कितना रहेगा नेक्स्ट? माइनस h क्रॉस स्क्वायर बाय 4m x cube plus here 2 to cancel m omega square x is equal to x0 is equal to 0. Okay, so this implies now you put the value of x is equal to x0. What will be your answer? Minus h cross square 4m, in place of x you put x0 plus m omega square x0 is equal to 0. So this implies this is minus h cross square plus 4m square omega square x0 to power 4 is equal to 0. Understood?
Yes, sir.
सर
Yes, sir.
Taking the LCM will be multiplied to 0 is equal to 0. So this implies what is the x0 to power 4? 0 to power 4 is right hand side plus h cross square divided by 4m square omega square. So this implies x0 square is equal to h cross by 2m. This is 4. I want to square root, take the square root. H cross by 2m into omega. This is equation number 4. Okay? Now,
Yes, sir.
so we got x0 square. Okay? Now, hello? Okay.
Yes, sir.
यस सर
Using this equation 4 and equation 3 and 4, we can find the minimum energy. So right, the minimum energy at ground state will be obtained. The minimum energy at ground state will be obtained by putting the minimum energy at ground state contradiction. Okay. So
Yes, sir.
hence, the ground state energy of linear harmonic oscillator is not equal to 0. Hence, the ground state energy of linear harmonic oscillator cannot be 0. Ground state energy of linear harmonic oscillator cannot be 0. But classical physics said that it is 0. Okay. Bujela?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir. Yes, sir.
Okay. So this E0, tamko exam re, on your exam, if long question ask up to this, you have to write. So E0 is equal to H cross omega by 2, which is not equal to 0. It is a non-zero quantity, and this non-zero quantity is called as 0 point energy. So this is known as, you can write, this is known as 0 point energy. 0 point energy, all have written. What is 0 point energy? Maximum students, they have written, it is 0. Whether it is 0? No. What is the value of 0 point energy? This is H cross
H cross
omega
omega by
by
Cross
Cross
by
omega by
2.
2.
Very good. So by using the uncertainty principle, we proved 0 point energy is not equal to 0. It has value H cross omega by 2. So again, the next application, right? Non-existence STENCE, non-existence of electron inside the nucleus, non-existence of electron inside the nucleus. Okay. So have you written the heading?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is a very beautiful concept. You know, everybody we know the electrons are revolving around the nucleus. So whether electron is present inside the nucleus? No. Only proton and neutron are present inside the nucleus. But experimentally, it has been seen that in case of alpha decay and beta decay, look here, I am drawing the diagram. I am showing you alpha decay. This is A, Z. This is the parent nuclei or the parent nucleus. From the parent, we got the daughter. X with the parent, Y with the daughter. This is atomic number Z reduces to 2, Z minus 2. And this is what? Mass number. Mass number reduces to 4 and we are getting the alpha particle. What is alpha particle? This is helium 2. Okay. But in case of same parent nuclei, we are getting the daughter having same mass number, atomic number increases by 1. What is this? The beta particle. This is known as beta particle and this is known as alpha particle. So this is, look here, parent, daughter, mass number remains same, atomic number increases by 1 and this is the beta particle, or we can say it is electron, E0 minus 1, this is electron. Am I right?
Yes, sir.
Yes, sir.
Okay. So that means people, the scientist, the physicist thought that since it is a parent, from the parent we are getting the daughter, we are getting the electron. That means the electron is present inside the nucleus. If electron is not present inside the nucleus, how the electrons will come out from the nucleus? So in case of beta decay, people thought that this electron is present inside this parent nucleus. Okay? All of we know that revolving around the nucleus. But only one exceptional case, that is in case of beta decay, it has been seen that the electron is coming out from the parent nucleus. Okay? So this is one exceptional case. But by using the Heisenberg principle, I am going to show you that there is no chance of electron inside the nucleus. Absence of the electron inside the nucleus. Okay? Okay. So let's start. Let's see whether this electron is present inside this parent nuclei or not. Okay? Understood?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So let's begin. Okay. So the correct information is no electrons stay inside the nucleus, but it is one exceptional case. Okay. We are going to show whether this is present or not. Okay. Now, right. Electron is present. Electron is present inside the nucleus. Inside the nucleus. Nucleus means this parent nucleus. You see, this is the structure of the nucleus. Let electron is present inside the nucleus. Okay? So if electron is present inside the nucleus, okay?
Yes, sir.
Right. Since the diameter of the nucleus is of the order of do you know what is the always we are acquainted with the electron, proton, what is the remember? So it varies from atom to atom. But the diameter of the nucleus is of the order of 10 to the power minus 14 meter. Okay. So this is the diameter. And we have taken the assumption electron is present inside the nucleus. Okay. So if electron is present inside the nucleus, we can write, so the uncertainty, uncertainty, the uncertainty in position of the electron, uncertainty in position of the electron is del x is equal to 10 to the power minus 14 meter. Means electron is present somewhere, maybe diameter, maybe this diameter, maybe this diameter, maybe this diameter. So we can say the uncertainty in position of the electron is 10 to the power minus 14 meter. समझ में आया सबको?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. According to HUP means Heisenberg uncertainty principle. Your del x into del p is equal to h cross by 2. So this implies del p is equal to h cross by 2 into del x. Okay. So this is equal to h cross means h by 2 pi into 2. What is the del x value? Expanded. H cross is equal to h by 2 pi. Again 2 is here, and in place of del x I have written 10 to the power minus 14. Okay?
Yes, sir.
Yes, sir.
Okay. Now, if you do calculate, you can find what is the value of h? 6.62, 10 to the power minus 34. 2 into 2 is equal to 4. Okay. So 4, what is the value of pi? 3.141 into 10 to the power minus 14. If you calculate, you can find this is equal to 5.278 into 10 to the power minus 21 kg meter per second. So we got del P is equal to 5.278 into 10 to the power minus 21 kg meter per second. Okay?
Yes, sir.
Yes, sir.
Let this del P, the del P be the uncertain. This is not correct. Let the del P is equal to P, which is equal to 5.278 10 to the power minus 21 kg meter per second. We have taken the assumption. We got del x and we got del p. Okay. Since the minimum value of linear momentum of the electron is of the order of del p, we have to calculate the minimum total energy of the electron. Okay. So after that you can write a relativistic energy of the electron, relativistic energy of the electron is E is equal to, the one formula here you have to remember, that is E is equal to m0 square C4 P square C square under root. So this is the relativistic energy formula. You see that there are various formula for energy. You know potential energy, kinetic energy. Okay, and E is equal to mc square. Energy of the photon is equal to h nu. But here the relativistic energy is this, where m0, many times I told you, is nothing. The rest
Rest
mass
mass
of the
of
electron, the rest mass of the electron, which is equal to 9.1 10 to the power minus 31 kg. Okay. C with the, what is C?
speed of light.
Speed of light.
Speed of light, which is equal to 3 into
10 to the power 8.
10 to the power 8 meter per second. Now putting all the values in this equation, suppose this is equation 1, putting and P with the, you can write the P we got 5.278 into 10 to the power minus 21 kg meter per second. So right, putting the above values, in equation 1. Putting the above values in equation 1, we get E is equal to M0. M0 means 9.1 10 to the power minus 31. Kete ko?
kg.
Square.
Square into
C
3 into
hochi
10 raised to 8 ର fourth
3 into 10 to the power 8
10 to the power 8 4.
to the power 4
M ଜାଗାରେ କେତେ ଲେଖିବି?
plus p square 5.278 into 10 raised to minus 21 ର square
Square. Next,
into 3 into 10 raised to 8 ର square.
square root. Okay. If you put all the values, 9.1 into 10 to the power minus 31 square into 3 into 10 to the power 8 4 plus this, if you do calculate, you can find this implies it is approximately equal to 10 MeV. Remember, huge amount of energy, mega electron volt. So that means if electron exists inside the nucleus, their energy must be of the order of 10 mega electron volt, because we have taken the assumption electron is present inside the nucleus. But the electrons emitted from the nucleus in a radioactive beta decay have kinetic energy of about 1 MeV, which is much smaller than predicted by the HUP exist inside the nucleus. Understand? Am I audible?
yes sir
Yes, sir.
Yes, sir.
Yes, sir.
So, if electron is present inside the nucleus, we are getting if electron is present inside the nucleus, we are getting the energy of 10 mega electron volt. Okay, but practically in case of beta decay, the electron coming out from the parent nucleus having energy 1 MeV, which is much smaller. Okay, so our assumption is wrong. So right, that means if electron exists inside the nucleus, then their energy their energy must be their energy must be of the order of their energy must be of the order of 10 MeV. But nucleus, electrons emitted from the nucleus in have kinetic energy of about 1 MeV, which is much smaller than which is much smaller than which is much smaller than that predicted by HUP predicted by HUP. So electron do not exist inside the nucleus. So electron do not exist inside the nucleus. Okay? Soumya,
Yes, sir.
read. कौन लिखिल पढ़.
Sir, that means if electron exists inside the nucleus, then their energy must be of the order of 10 mega electron volt. But the electrons emitted from the nucleus in radioactive beta decay have kinetic energy of about 1 mega electron volt, which is much smaller than that predicted by Huygens uncertainty principle. So electrons don't exist inside the nucleus.
Okay. So very good. Up to this you have to write. Okay. This is also one of the important 5-mark question. Prove that electron do not exist or absence of electron inside the nucleus by Heisenberg uncertainty principle. Okay. Pragya, likhilo.
Yes, sir.
Okay. So this is all about the Heisenberg principle. Next, write wave function. Wave function. So wave function means this is psi. This is the symbol of psi. RT. Psi RT denotes the wave function. Okay. So this is the state function which contains all informations about the physical system. It's called as the wave function. So mathematically, we can write psi RT is equal to A e to the power I k dot r minus omega t. देखो The wave function, it is a function of r and t, which is equal to a e to the power I k dot r minus omega t. Okay, so here a is known as amplitude. What is a? A for A for
Amplitude.
Amplitude.
amplitude. The k vector is known as wave propagation vector. The magnitude of the k is equal to 2 pi by lambda. Omega is known as angular frequency. Omega is known as angular frequency. Okay. Next, R is known as, who can say what is R?
position vector.
R is known as position vector, which is equal to x I cap, y j cap, z k cap, is known as position vector, and t for time. T for time. Okay. So these are the this is the wave function. Mathematically, we can define the wave function like this. Okay. Next, the properties. What are the properties of the wave function? Right. Properties. Sometimes 2 mark question or okay. So right. Number 1, it is a function of space coordinate and time coordinate.
Sir,
Yes,
space
sir.
coordinate.
It is the
And time.
function of space coordinate in bracket x comma y comma z. It is function of space coordinate and time coordinate. Number 2. Okay. The I is there. What is I? I for imaginary number. What is the value of I? I is equal to minus 1 under. ଜାଣିଛ ନା ନାହିଁ?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So since I is present, it is a complex or it is a real?
Complex.
Complex.
Yes, right. Number 2, it is a complex quantity. So it is a complex quantity, so it cannot be measured. It is a complex quantity, so it cannot be measured. Salah?
Yes, sir.
Yes, sir.
We cannot measure the complex quantity. Number 3, it is a single valued function. It is a single valued function. Psi has a single value, not multiple values. It is a single valued function. The 4th point, psi and its partial derivatives are continuous everywhere. Psi and its partial derivatives are continuous everywhere. So partial derivative means del psi by del x, del psi by del y, del psi by del z are continuous everywhere. In bracket, it is a square integrable function. And its partial derivatives are continuous everywhere. If you take the wave function and its partial derivative del psi by del x, del
सर
psi by
ब्रैकेट रे
del
कौन लिखे
del
bracket
psi
रे
by
it
del
is
z.
square.
नहीं ब्रैकेट नहीं, psi and its partial derivatives are continuous. Psi and its partial derivatives, you can write this as a bracket. Psi and its partial derivatives in bracket are continuous everywhere. The next point, it is a square integrable function. It is a square integrable. Square integrable means if you integrate, the value will be 1. If you take the wave function, you take the mod square, if you integrate, the value will be 1. The next, it must satisfy Schrodinger's equation. It must satisfy Schrodinger's equation. Okay? It must satisfy Schrodinger's equation. Likhi it is Schrodinger.
Yes, sir.
It must satisfy Schrodinger's equation. So we have to discuss that Schrodinger equation. Okay? Suryamai Sahu,
Yes, sir.
you read the first point. कौन लिखिला?
It is the function of space coordinate and time coordinate.
It is the function of space coordinate and time coordinate. Space coordinate means x, y, z. Okay? Psi consists of space coordinate x, y, z. Others visual. What is the next point?
It is a complex quantity, so it cannot be measured.
Very good. Due to the presence of I, it cannot be measured. It is a complex quantity. Next, Chinmay Sankhwa. The next point. Chinmay Behra. Huh? कौन है चिन्मय? आदित्य बेहरा.
Yes, sir.
What is the next point? Third point.
It is a single valued function.
It is a single value. Psi has a single value, not multiple values. Parichay Panigrahi. Next point. Parichay Panigrahi. Prince Prabhakar. Those who are not responding, I shall not give you the attendance. Be quick. Choice is yours. Prince Prabhakar. Who is saying? What is the next point? What is the next point? Aman Ujjwal Topo. What is the next point? Ashirvad Mantri.
Yes, sir.
What is the next point?
Psi and its partial derivatives are continuous everywhere.
Okay, very good. Vikas Bhol. What is the next point?
So it is a square integrable function.
It is a square integrable function. Next point, Dibyanshu.
So it must be satisfied Schrödinger's equation.
It must be it must satisfy Schrodinger's equation. Okay?
Yes, sir.
Yes, sir.
Okay. So next we'll see what are the dimensions. What are the dimensions of the wave function psi? Dimensions. Dimension, you know, we have to, the powers of the physical quantity are known as the dimension. So here the dimensions in 3 dimension is L minus 3 by 2. If you take in 2 dimension, the dimension formula is minus 1. In 1 dimension, this is minus 1 by 2. Okay. So in 3 dimension, L power minus 3 by 2 or other terms are 0. In 2 dimension, L power minus 1. In 1 dimension, L power minus 1 by 2. So these powers are known as the dimension. And after putting the bracket, it is known as dimensional formula. Okay?
Yes,
Okay.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Next, you have to find. So probability density means this is a rho density, which is equal to psi mod square. Remember, if you take psi probability density, psi mod means it is a psi star into psi. How to find psi star? Psi star is known as complex conjugate. Complex conjugate. What is complex conjugate? Who can say? How to find the complex conjugate? Who can say? How do you represent a complex number?
A plus IB.
A plus IB. Very good. कौन आउ के जानी ना कौन? The complex number means A plus IB. So here A is real, B is real. So what will be its complex conjugate?
A
A
minus IB.
minus IB. Yes. Only you change the sign of the imaginary part. A plus IB, A minus IB. If you multiply complex conjugate with the original number, then you can find the psi mod square. So psi mod square is equal to psi star, that means complex conjugate, with the original function. If you multiply, you can find the probability density. But total probability density, total probability density is rho dv integration, answer is equal to 1. You remember, the total probability will be always 1 or 100%. So in quantum physics, how do you find? You find the probability density, and if you integrate with the dv, the right hand side will be 1. So it is known as total probability density. Okay?
Yes, sir.
Next, Schrödinger equation. Schrödinger's equation. Okay. Schrodinger equation means the equation which describes the wave nature of the particle in mathematical form is known as Schrodinger equation. So Schrodinger equations are of two types, time dependent and time independent. So we have to find time dependent Schrodinger equation. In short, we can use TDAC. TDAC means time dependent Schrodinger equation. Okay, so time dependent means in the equation time factor will be present. So time independent means there will be no time. Okay. Okay, समझ
Yes,
में
sir.
आया?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Next class we have to continue. I have to close here. Okay. You have to give your phone attendance. Serial number 1,
Present, sir.
2,
Yes, sir.
3,
Present, sir.
4, 5, 6, 7,